Welcome back. In this video, we're going to solve exponential equations. Now recall that an exponential function is expressed f of x equals some base a raised to some unknown power. So f of x equals a raised to the x power. Or an exponential equation might take the form a raised to the x power equals some other value y, or some output y. So here's an example of an exponential equation. 25 raised to the x power equals 125. So what power do we have to raise 25 to get us to 125? Well, we have a process to do this. And in order to solve an exponential equation, we must have the same base on each side of the equation. So if we don't have the same base, we'll have to express each as a power of the same base. So knowing your laws of exponents will help you out here. So let's follow our process here and let's solve together 25 raised to the x equals 125. Well, 25 and 125 have a common base of 5. So now we can rewrite 25 with base 5, which is 5 squared. So 5 squared raised to the x power. 5 squared is 25 raised to the x, and 125 is 5 cubed. So we have 5 squared x equals 5 cubed. Now we have the same base. The second step is to apply the laws of exponents to simplify the exponents. So I have a power raised to a power here. So this becomes 5 to the 2x equals 5 to the third power. So power raised to a power and multiply the exponents, so I get 2x in my exponent here on the left-hand side. Now that I have the same base, my process says drop the base and rewrite the equation using only the exponents. So if I drop my base, I can rewrite this just as 2x equals 3, and then I solve for x, divide both sides by 2, and we get x equals 3/2. So sure enough, 25 to the 3/2 equals 125. If we remember our rational exponents, it's power over root. So this would be the square root of 25, all raised to the third power. Does that equal 125? It sure does. So square root of 25 is 5, and 5 cubed is indeed 125. So let's do a second one here, a little bit more complicated. We have 4 to the 3x minus 1 equals 16 raised to the x plus 2. Well, we have base 4 and base 16, so we can easily rewrite this in base 4. So we have 4 to the 3x minus 1 equals, well, 16 is 4 squared, all raised to the x plus 2. So a power raised to a power, we have to multiply our exponents here. So we get 4 to the 3x minus 1 equals 4 to the 2x, and we distribute the 2 to the 2x plus 4. So now I have the same base, so I can drop my base and simplify the exponents. So 3x minus 1 equals 2x plus 4. I'll subtract 2x from both sides. I will add 1 to both sides, and I get x equals 5. So 4 to the 3x minus 1 should equal 16 to the 5 plus 2. So 4 to the 3 times 5 is 15, minus 1, 4 to the 14th equals 16 to the 7th power. So that should work out. There's one way to check, and that is, in this particular problem, I'm going to ask you to confirm our answer by using base 2. Now this doesn't happen all the time, but because of the numbers we have in our sample problem with the 4 and 16, 4 and 16 both share a common base, base 2. So now I'm going to ask you to redo this problem with base 2. So 4, you could write that as 2 squared to the 3x minus 1 equals 2 to the 4th, that's 16, to the x plus 2. So I will ask you to follow the process we did here on the left, apply the laws of exponents, set your exponents equal to each other, solve for x, and please go ahead and confirm the answer, and then I will see you in class.